of matter and its changes. So if we're studying matter, there's a lot of matter. Matter is everything composed of atoms. That's everything in the universe that's composed of atoms, which is basically everything you can see and not see, not including energy. So we'll be talking a lot about the changes matter undergoes. Those are chemical reactions. And we'll be working our way up to that, because chemical reactions is the name of the game in chemistry. And if you have a lot of stuff, the first thing you want to do with all that stuff is you want to organize it. So this is organization or classification of matter, and by its physical state. Okay, so there's different ways to organize matter. This is one way, and this is by describing it by its physical state. So matter exists as one of these 3 or 4 main physical states. The most common that we see are solids, liquids, and gases. Okay, plasmas are actually pretty common. They're just not talked about as much. So plasmas are hot ionized gases that can conduct electricity. There's also a super cooled gas called a condensate, a Bose-Einstein condensate, which is a 5th state of matter. But plasmas are important in plasma screens, plasma televisions. So the more common that we see in chemistry, though, are solids, liquids, and gases. So physical states are defined by the spacing and motion of the particles in that substance. So solids are very close together and have no motion, okay? Maybe just some vibrational motion. Liquids are still relatively close together, but because there is some motion, there ends up being some spacing. So these particles start to move apart from each other as they would have started as a solid. Okay, and how did that happen? A solid becoming a liquid when energy is added. So adding energy causes some of these particles to move apart from each other from the solid, and then you end up with some spacing. When you add even more energy, you end up with these particles moving faster and farther away from each other. And so there, for gases, there is a lot of motion and a lot of spacing as a result. But now let's look at just by its composition. So atoms exist as either substances, or what are called pure substances, or mixtures. Okay, just taking it and saying, what is it composed of? Okay, so substances or pure substances are small scale. We can't see any of these. Okay, we cannot see substances. We can't see elements or compounds, at least not on an individual level. So we can't see elements. Examples of elements are single atoms, a single box on the periodic table. So an example would be like the element silicon, which is this element symbol Si. Okay, or when you put those compounds, you put those elements together, when you bond the elements, you're ending up with a compound. And a compound is when you have atoms bonded together by a chemical reaction, and you have to have 2 different types of elements. So 2 different types of elements bonded together in a chemical reaction, like silicon bonded together with oxygen would give you SiO2, silicon dioxide, which is something we'll talk about more when we go back to smartphones and glass and sand. So this is a compound because it has 2 different types of elements. It has the silicon and the oxygen. Okay, so whether you're talking about elements or compounds, these are both symbols that you'll see in the periodic table. Those are subset of substances. Mixtures are larger scale, and we can see mixtures generally, not all mixtures. So there are heterogeneous mixtures and homogeneous mixtures. Heterogeneous mixtures are varied in composition. This is something where we can see the parts. An example being gravel or sand. You can see the different particles in sand or the different particles in gravel, or soil. You can see the different parts in there. Versus homogeneous, you can't see the different parts. You know that there are different parts in there, but you can't see those different parts. An example of this is sugar. If you've ever dissolved in water, you know that there are two parts. There's sugar and there's water. But once it's dissolved, you can't see those parts. And that's because it has a uniform composition. That's called a homogeneous mixture. So a heterogeneous mixture is variable composition, and you can see the composition basically. Homogeneous is uniform, and you cannot see the composition. Okay? And so going back here is that pure substances, okay, and mixtures, that's the main breakdown of matter. But then we can further break down substances to elements and compounds. Elements are basically atoms in the periodic table. Compounds are when you start to combine those atoms, and this would be having to have two different types of elements, or you can have 3 or 4 or more. And then mixtures, this is on larger scale, heterogeneous or homogeneous. So when you take all matter, you basically are taking something, trying to figure out what box it goes into. So first you ask, can it be separated by a physical process, like moving these to the left and these to the right? You can see the differences and separate. If the answer is no, you're talking about a pure substance. If you can separate, like you have a pepperoni pizza, you can take the pepperoni off and separate it from the rest of the pizza, then you're talking about a mixture. Okay, so for the pure substances, you take that and you ask, can it be broken down into simpler substances? So if this would happen by a chemical reaction. If the answer is no, you can't break it down, that means you're just talking about one uniform element, one element. You can break this down by a chemical reaction. You can take the unknown thing and break it down by a chemical reaction. Then you're talking about a compound because it must have been made out of more than one element, okay, more than one atom bonded together. So let's classify each of these as an element, compound, or mixture. If you're talking about copper, so this is the element symbol Cu. Anytime you have an element symbol from the periodic table, then you're talking about an element. Okay, so that is a pure substance. The helium filling in a balloon. So when you have the element symbol, that's going to be an element, and that's going to the subset of the pure substances. Okay. A sample of laughing gas, dinitrogen monoxide is the name. We're going to be getting into writing chemical names and chemical formulas in a future lecture. But here is a chemical formula for this dinitrogen monoxide. So N2O, you can see that there's nitrogen and oxygen. Those are two different elements. So now you're talking about a compound. This again is a subset of pure substances. Okay, water. So water has the chemical formula H2O. There's 2 hydrogens and 1 oxygen. Those are 2 different elements that are bonded together. So this is a compound. And that would be of this in the substances. If you have steam coming from a boiling pan of water, okay, so water boils, it produces steam. That is not a chemical reaction. That's a physical change. Why? Because in a chemical reaction, you have to have bonds broken, new bonds formed, and this is not what's going on. When water boils, it turns from a liquid to a gas. This is because you're adding energy, and it causes the particles to move apart from each other. The water molecules gain energy, and they move apart from each other, and instead of being close, relatively close, then they're far apart from each other. So this is a physical change, and what you have, though, is you still have water, and that's still going to be a compound. Okay, fluorine. So fluorine has the element symbol F, and fluorine is an example of a diatomic molecule, or what's called a molecular element. You have 2 fluorine atoms bonded together. That's how this would look like. There are 2 fluorine atoms bonded together, and it is, even though they're 2 atoms, they're the same atom. So this is one single element. even though two atoms of that one element. Okay, so it's not a compound. A compound has to be two different atoms, two different elements bonded together. So let's say you have a bar of deodorant soap that's various organic compounds. So you look at that soap and can you see those different parts? I'd say, let's say you can't see the parts. That's an example of a homogeneous mixture, but we're only asked to classify it as a mixture. Because you might be saying, well, I can see this streak of white in my deodorant soap compared to a streak of green. Homogeneous or heterogeneous, if you can't see the parts, it's homogeneous. If you can see the parts, it's heterogeneous. But either way, you have a mixture of substances, various organic compounds. A cup of mayonnaise. So mayonnaise, for all you chefs out there, know that there are all kinds of organic compounds in there. There's egg, there's oil, there's water. So what you have there is a mixture again. I can't see those different parts, so this would technically be a homogeneous mixture, but we're only asked to classify by mixture, compound, or element. Table salt. We're given the chemical formula NaCl. So this is two different elements, the symbol Na compared to Cl. So two elements bonded together is a compound. That's a subset of the pure substances, or just substance. And then you have seawater. Seawater is salts dissolved in water, such as sodium chloride dissolved in water. And so when you have salts dissolved in water, and you're talking about a mixture.